Welcome back to the Automate Construction Podcast. We have an absolutely epic episode today that I've waited for a long time with Dr. Barak Koshnevitz, the inventor of 3D printed concrete as we know it today. You guys are very familiar with on this channel. You founded Contour Crafting over 20 years ago, right?
Yes, well, the company was started in 2017, but the idea of construction scale 3D printing, which I named Contour Crafting,
Mm-hmm.
actually came to my mind in
In the 90s, when you
1994,
were repairing a
the
crack
90s.
in your home, you used plaster and a trowel.
Exactly. It was connected to the earthquake in 1994 in
Wow.
Southern California, right?
And so, can you tell that story, please?
Yeah, well, so in the morning we got up and there were cracks all over, especially the living room. And so one crack was really scary, so and didn't look good. So I decided to go to the hardware store and buy some spackling compound, the putty, to cover the big crack. And as I was doing it with this handheld trowel kind of thing, I noticed strong uh, capability of the simple tool in making very smooth surfaces. And of course, prior to that, those early years of 3D printing, I had got involved in these technologies, and I couldn't stop thinking about them. And I had come up with actually a method by then that I was working on mesoscale 3D printing.
At Berkeley.
Uh, no, at University of Southern
Okay,
California.
great.
I have been at University of Southern California at that time until now. Yeah, so uh, then I thought about somehow incorporating this simple tool in an extrusion nozzle, and uh, and then I thought we can create not only smooth surfaces, but it will allow us to have larger orifice, uh, which would make it possible to have complex material uh, to be passed through it.
Meaning larger aggregate size?
Right, or more complex material like even sand,
Mm.
excuse me, or filaments. I was working at the time on plastic stuff mostly. So I was using polystyrene and glass fiber and all that. So to be able to extrude that through a big nozzle and yet have a smooth surface, because in FDM, for example, if you use deposition, the resolution really depends on the diameter of the orifice.
Mm-hmm.
The larger it is, the coarser the print will look. But I managed to create smooth surfaces with very thick layers.
Which is
Very thick,
efficient for
right,
speed.
right. And that, of course, inspired the idea of, well, why not making bigger stuff and bigger stuff? And I started trying different materials, I remember, and trying spackling compound, plaster, and all that, or a kind of non-polymeric material that I started with. And gradually, I started thinking about, well, why not build buildings with this or walls or whatever. And so I started focusing more on construction materials. At the time, I didn't know much about cementitious materials, mortar, concrete. I still don't know really too much about them. They're complex materials. Um, but so I went to our civil engineering department. At the time, there was a gentleman who was researching in concrete, and I told him about the idea, and he totally shut the idea down. He said, well, "You don't know how concrete performs. You cannot make concrete stand on itself, keep its form, deposition." So later I understood the reason for him saying that, because uh, he was really thinking mostly on the status quo, about the status quo,
Mm-hmm.
where the high slump concrete is desirable to fill the cavities of formwork.
Mm-hmm.
To support concrete industry. Like, you don't want low slump concrete for that. And so he was right, but I had a different paradigm in mind. So, and then I was discouraged in a way that, okay, concrete is not going to work, but the idea is good enough for people to develop some other kind of material that would be good for construction.
Mm-hmm.
But at the same time, I was developing a polymeric 3D printing method called SIS, Selective Inhibition Sintering, uh, which worked with plastic powder.
Mm.
And I made a contact with different companies that made the powder, and one of them was Degussa, the equivalent of like DuPont in Europe.
Okay.
It was a German company specialized in materials. So I contacted them, and they provided this powder thing. Then the director of that powder division invited me to go there once, and when I went there, I spoke about my other activities in this, and then talked about potential in construction.
So they supplied the material and you built the hardware?
Yeah, right.
And what year was this?
Whew.
The 90s still, or is this early 2000s?
It was around 1994, I would say.
Wow.
Around the same time.
So it was really serendipity that you were working with these larger polymer printers at the same time that you bought the plaster to repair the crack from the earthquake.
Well, that experience at the earthquake inspired me to build uh, machines that would use fuse deposition for plastic, but with larger orifice
Mm-hmm.
and with an added trowel.
Interesting.
So I built for the first time large plastic parts with very thick layers with perfect almost surfaces.
Nice.
Uh, I still hadn't gone into the idea of building buildings and
Concrete.
whatever, right?
Got it.
Yeah, but later on I got into it. I told you I met with this gentleman in the civil engineering department about concrete. And when I went to Germany and spoke with that director of the powder division, he asked, at dinner time, said, "What else are you doing?" And I mentioned contour crafting. I named already the thing contour crafting.
Mm-hmm.
I said, "Well, do you know that we have a big construction division at the Gusa?" I said, "No, I didn't know that." He said, "Yeah, they can provide information." So he introduced me to the director of the construction division there. And that gentleman was pretty excited about what I talked about. He said, "Well, we can help you formulate the right concrete for
Low
it."
slump buildability.
All right, all that. And then they introduced a person at their branch here, which was called the Master Builders or something like that. And then that guy was really knowledgeable in concrete, and they brought different kinds of admixtures and materials and formulated them, and we started printing stuff, such as the one that is in the hallway here. I don't know if you took notice of it, but you can see it later if you didn't.
It's still quite challenging for people to come up with a formulation to print in a new area. So I can only imagine when nobody else had ever done it before,
Right.
coming up with the first one. How long did it take to get that first mix that would build upon itself?
Yeah. Before that, we were trying, and because we didn't know nothing about, we didn't know much about concrete, my students and I, and we could make stuff, but they either did not look too good, or they didn't have much strength. They had a lot of shrinkage. We would get a lot of cracks and all that. But when we got help from the GUSA, this thing, we built really nice specimens. As I told
Nice.
you, I kept one of the original ones there. And then the GUSA mentioned this uh, in their newsletter, internal newsletter, and somehow that got to Spiegel magazine.
Mm.
Before I knew, they sent a journalist to USC, and they asked a lot of questions and took a lot of pictures of my basic equipment in the
Sure.
lab. And then there was a 4-page article in the GUSA, in Der Spiegel magazine. It's a very famous European publication, a German publication. And then I guess later on, New York Times wrote about it and all that, and I was caught by surprise. What is this? This has not been that much of a challenge because as far as the technology was concerned, because the other thing, 3D printing, as I was working on, were more difficult in a way. Working with powder plastic. By the way, SIS in the end was licensed to HP. It's a technology that HP uses in their printers,
Mm.
and later on the metallic version of it and so on. So yeah, back to contour crafting. I kept my activity going, but it was hard to get money for it,
Mm-hmm.
and it was hard at a university like USC to get the space for the lab. I couldn't build anything big. My desire was to be able to build a big machine. Eventually, I got there in 2006. I built the first large gantry. At the time, Caterpillar and U.S. Gypsum were funding some way activities.
Interesting.
Yeah, and we built the very first wall, hollow wall in one shot with the hybrid nozzle that I had at that time.
What makes it hybrid?
I mean, it built the sides and as well as the middle,
Okay.
right?
So it would two different materials, one for printing and one for the infill
Yes,
structurally.
you could have had that opportunity to do that too, but still, it is what I developed back then is the most complex kind of nozzle that exists. After more than 20 years, there has never been anything as complex as that. You can see that in the conference room. The video you probably have seen, the nozzle creates a hollow
Mm-hmm.
wall with corrugated internal structures. So U.S. Gypsum took that to Chicago for their museum, and I still is there. And then came the 2008-2009 recession, and the real estate went down, construction went down, and
Investor funds dried up.
yeah, exactly. A number of people that were working with me, my contacts at Caterpillar and U.S. Gypsum, were laid off actually, and so the situation became grim to me. So I said, well, what else can I do? Where else can I go where there would be an application for it? And that's when I started thinking about space and building on Moon and Mars. So I started reading a book about the moon, and I contacted a couple of people in our astronautics department as well. And then, based on the little knowledge that I gained, I put a story together and participated in a NASA, responded to a NASA solicitation through a prestigious program called the NASA Innovative Advanced Concepts, NIAC. A lot of people who wrote proposals to them were internal NASA researchers, plus others with experience. About 800 proposals were submitted, and they picked 30, and my proposal was one of the 30 to be awarded. And so for a few years, I was now only thinking about the space, and my PhD students were working on the space issues. So it was space material, space conditions. And I made basically two demonstrations for building on Moon and Mars, and I used simulants, simulants of the regolith
Yeah.
for Moon and Mars, and uh, one thing was basically a variation of contour crafting through thermal nozzle, and that one won an international competition grand prize in 2014. And then another one in continuation of my NASA project, which was focused on horizontal structures, and especially landing pad. I developed another technology, which later on became a general purpose 3D printing process for metals.
That you licensed to HP.
Yeah, that one was also licensed to HP. So,
Okay, a second license.
all right. Well, then that one also in 2016 won a grand prize in an international competition that NASA sponsored. So,
And that's when you started the company in 2017, officially.
2017, right. But now I really wasn't thinking about starting a company, but I was being approached around 2015, 2016. I was being approached by different companies around the world. I was invited to different conferences and all to talk about this.
In Denmark?
Everywhere. Denmark.
I saw you did TED Talks, Kish, Medellin. You did TED Talks everywhere.
Well, you do your homework. That's great. Yes, TED Talks. Yeah, the first TEDx talk that I gave here in 2012, that really excited the curiosity of a lot of people. You know, like a couple of million views back then, and after that, there are still people looking at it, and that gave me some satisfaction that hey, I have spread the concept that could actually happen. And later on, as I told you, I was being approached by different companies here and in Europe. And in 2017, finally, I decided to start a company, and with the investment of a European multinational construction technology company. And we have been working on our mission since then.
Doka.
Yeah, Doka is one of the subsidiaries of that company. It was Umdash Group. Yeah, so it was a great company. I thought it was very relevant to our direction and all.
And it had clearly captured the attention of the world.
Right. So Contour Crafting Corporation was the first funded company in this field. However, we have not made really too much noise since we started, because we took on very challenging projects here, you know, and first our investor pushed us towards complex directions, which were not necessarily in our business plan, but I was challenged, therefore I thought it's an exciting direction.
Investors ruin everything sometimes.
Right. So when I look back at the passage, I noticed that really most of it could not have been preconceived or pre-planned. I been teaching a course at USC on invention and technology development. And most of the course is about what I have learned in the world of invention and innovation. And I've learned the fact that I just told you that you cannot really chart every step of the way, all the way. Because first of all, you don't have knowledge of how the world is. You don't know about the interactions. You don't know about butterfly effect, possibly impacts, things like that. That happens uh, in nature all the time. But the important thing, as I tell my students, is to be always on the move. Because when you move, there is a possibility of you running into something uh, fortuitous, that leads you to something. But if you are stagnant, the chance of anything coming to you is small.
You clearly demonstrated that, for example, in 2008 when the market changed, you were able to shift directions.
Right. Otherwise, if it wasn't because of that incident, the recession in housing, I would have never thought about the space. It was situation was like being cornered. I already had this lab at USC. I had students that I had to support. I needed funding to get this thing going. I already had a liability on my hand. So again, that's another thing, a lesson in life, that sometimes when you're cornered, it's not all that bad.
Oh, yeah.
You see, that's when new things come to your mind.
You talk about the butterfly effect. One of the butterfly effects is I have a job making videos.
Yeah,
If you
right.
hadn't come up with the concept, I don't know what I'd be doing with my life.
Right,
And we have never met before today.
right. And you're doing an exceptionally
Oh, thank you.
valuable job.
I just realized the hybrid nozzle you were talking about.
Right.
I was thinking it was pouring concrete into the center, but you were talking, it's the structural printed infill, the corrugated. So you would print
Right.
3 lines at one time,
Right.
2 straight, and then 1 going back and forth
Exactly.
as the system moves down.
Right.
That's incredible.
So those technologies we have had, and in this company we've had the newer challenges as well that we have been struggling with, and we have had some successes. And our activities in this company, commercial activities, we have really not had much, but we have had contractual projects with U.S. government.
The military?
Yes, but right, and we have been working. I've been working closely with Army Corps of Engineers for emergency shelters and all that for a long time, and these are all connected to the same original kind of activities. Right, so this is where we stand right now. We have 3 different machines right now that we have developed, and they're actually ready for commercial market, but I'm contemplating on the timing of it to basically make sure that we will be in the market for doing something meaningful. I didn't attempt to make demonstrations. First of all, logistically, it was difficult for me while I was at USC to build a whole house or whatever. I wasn't even really totally free to build a building inside the lab, because that was a liability with students and all that. Technology hasn't been tested or all that. They will say, oh, what if there is a little earthquake and student gets hurt or whatever. So everything was done conservatively, just enough to give us the information worth having. Yeah, that has been the story of contour crafting so far. It was started on Earth and went to space and came back here. And I don't know where necessarily it's going to go uh, in the foreseeable future, but my aspiration is to create as much technology as possible while I'm still around, right? I'm not a young entrepreneur that has got many decades ahead, so I have to budget my time carefully and between the business and innovation, my tendency is really in creating more innovative stuff.
That's great to hear because I always love to see more new technologies in the pursuit of construction
Uh,
automation. Um, what was your motivation for creating AC 509? You were a key component of that, right?
right, but again, things happen when you move, as they say, as I said earlier, but others have said that too. Uh, I was giving a talk uh, at a for a group in which International Code Council people were there.
Hmm.
In fact, their president was there. And after my talk, I was approached by the president of ICC, uh, Dr. Shaheen uh, Moinian is his name. And he is the one who suggested that, well, it is time to create a set of guidelines for this. And he introduced his related staff, uh, Dr. Mahmoud Eknel and Miss Melissa Sanchez. We had some early preliminary meetings, and then I got my former PhD student who was working at this company involved, Dr. Ali Kazemian, and I also involved Dr. Bora Genstork of USC Civil Engineering. His field is material, and he's got a very sophisticated lab on structural engineering, which is accredited actually now by ICC to do tests.
Hmm.
He has done a few
Yeah.
related tests. And also from HDR, there was there were engineers who looked at what we were drafting, and then they approved it as Mr. Chalangarian, I think this was his name. He's very experienced engineer there who were involved. And then this was the beginning of everything. And after the first draft was created, there was a public hearing. Yes, directors of several construction industries participated there. And it was time of voting
Hmm.
on approving this new uh, guideline,
Did they approve the
basically.
first draft or were there revisions?
After that, there were some minor revisions, I think. Like, for example, that first draft referred to the machines as gantry machines,
Hmm.
which limited that to that. And it wasn't intentional, but so some people brought it to our attention that has to be,
More vague.
would be better, yeah, to be generic.
Did you
Um,
get the feeling that they were trying to help the technology grow, or were they afraid that if a new technology came, it might disrupt the way they were currently doing business?
I have not actually observed that kind of resistance, you see, so far.
Good.
Maybe it exists and I just didn't encounter that. And when I read about the history of inventions, I notice that that has been the case in a lot of situations. But construction industry, to me, I know very I cannot say I know a lot about it. But they have been open, but very skeptical
Mm.
from the beginning. And at the beginning, I just couldn't understand uh, the reason for their skepticism. If you look at my TED talk initially, you'll notice that I'm very, very optimistic about the future of this. So part of it was because I was naive, I didn't really know a lot of critical factors that are involved. But later on, it gradually became clear to me that, hey, construction industry is not dumb. In fact, it's pretty smart, right?
Very competitive.
Right. Um, they are in a field which is highly, of course, regulated. That's one big thing. It's like drugs and an FDA kind of situation.
Especially in California where you have wildfires,
Right.
earthquakes.
Right. So that's one special barrier. Like the small scale 3D printing doesn't necessarily encounter. But anything construction related, construction materials, uh, processes for building stuff and so on, they are under close scrutiny.
All of a sudden, you have to convince the banks, the insurance companies.
Right. So these are all some of the barriers against construction 3D printing, which basically slows down the adoption. But the most important factor, I think, even more serious than that, is the economy of the technology. What economy does it offer? Is it really beneficial to switch to this? And like every, I would say, disruptive technologies, this technology is also going to have a rough time early on. There are early adopters that adopt them, but in number, they're not going to be that huge. But gradually, it's going to grow. And as the technology matures more, and as also the economy changes, people are going to get more and more expensive. Labor is going to get more and more expensive. And it gets to a point, the break-even point, where now the other alternatives become more attractive. And reality is that 3D printing does not build a home. It just builds a portion of the home, maybe at best around 30% of the value of the building, just the shell of the building. That's another kind of consideration that one has to have when evaluating these. My vision, soon after I came up with this idea, was to also dream about potential of concurrently building, reinforcement into a structure, doing automatic plumbing, even automatic electrical network installation and all that. And I still think all of that are possible. But just the very first step already is a challenge in many respects. The cost of material, that's one big hurdle, right?
You mentioned early on that maybe the material could be something different than concrete.
Yeah, it could even be that, and maybe people may come up with alternatives.
Like what?
Different kinds of polymers, maybe, thermosets.
Adobe?
Adobe, right. Adobe is a good potential. This company in Italy has been, just from the beginning, has been focused on Adobe material, clay material. And I forgot to tell you, I did that along with plaster and stuff. I worked a lot on clay. One PhD student of mine entirely worked on clay and created beautiful geometries and all at a smaller scale. If you have seen it, the video, uh, and I still think that clay is a good potential. I
I do
worked,
too.
yeah, I worked with a operation here, non-profit operation here called Cal Earth.
Hmm.
An architect, another Khalili, and I worked together on some concepts. That unfortunately he passed, but I think that there is a lot of potential in earth-based material and 3D printing.
Absolutely. AC 509, a couple of the stipulations, it said no two-story buildings, right?
Right.
Uh, and there's a lot of testing requirements. Uh, do you think the testing requirements made it more cost prohibitive, or are they required?
Well, I know that it discouraged a number of material
Hmm.
providers, right? For example, the requirement of shrinkage of less than 0.04%, right? Not too many companies are interested in developing that material,
0.04%.
right? So they said, yeah, of course we can make this material, but it will be so expensive that nobody wants to use them. And a few companies actually developed that material, and they priced it at close to $1,000 per cubic meter,
Or more.
or more probably. You know better. Yeah, so that's the case. When the regulation becomes stringent, that's the thing. I think yeah, material right now is a big issue
Hmm.
in 3D printing because yeah, you save on the cost of labor and you are fast, but your material is super expensive compared to I don't know $150 of ready mix material for poured concrete.
40% cement usually, or 45.
Right. Right. So uh, then, if you want to compare it to conventional construction, the advantages that they have uh, is that really for building construction there is no equipment,
Hmm.
right? If you're not talking about high rises or anything, right?
Load the truck up with lumber, get a hammer, some nails.
Yeah, just an nail gun and saw and stuff like that, and then they build the whole building, and they don't have to have a machine that they have to worry about having expert operators and having maintenance program and having a place to store it and paying for the rent for that place. So if you add all of these up, then you'll notice that at least for like there are about 28,000 or 38,000. My memory is not serving me well with these numbers. Uh, Ma and Pa construction companies in the United States, several thousands of them,
Hmm.
and they build a good portion of the buildings here. I mean, homes here, and those guys will not be interested in this paradigm. A friend of mine is a builder, and he's an architect and civil engineer too. And as long as I have known him, I've known him for many years. He has never had a physical place for his company. Always operated out of his home office.
Okay.
He never had permanent employees.
It's
So
contractors.
whenever he gets a project, he just calls people that he knows. Some of them are available, some not. But he puts a team together pretty quickly and embarks on that project without needing to keep them after uh, the
After the project's
project is
done.
done. But if you have invested yourself in an expensive machine and you have hired a couple of technical staff to operate and maintain that machine, you cannot tell those guys to go after a project is done because you're not going to be able to easily find them again. So you have to therefore make them permanent employees.
Yeah, it's fairly uncommon for most construction companies to own their own equipment.
Right.
But in a rental environment, you could see it being easier. I guess it's just such particular equipment; it needs to be cleaned so well in between each use. Maybe it's hard to get people to treat it properly in a rental
Right.
situation. It's fascinating that you foresaw a lot of the problems that we're having today. Like it's more challenging to find construction labor. The costs have increased
Right.
from 20 years ago. Those problems are much bigger now, right? If you talk to your contractor friend, is it harder for him to find labor now?
Yeah, it is. It has become harder, but it's still. It takes a while before we get to that break-even point.
Sure.
We're not there yet, but eventually it's going to be the case. You know, I don't think uh, people are going to really use their muscle to earn bread
Yeah.
for too long.
I
You
think
see,
that's why it captures the world's attention so much because
right,
so many young people want to work with their minds and be the next Elon
right,
Musk instead of
exactly.
working with their hands.
And philosophically, uh, I believe anything that machines can do is really inferior for humans to do. So therefore, robotics and automation and AI, all of them make sense.
Hmm.
You see, and the future is going to be a very different kind of setting. And just look at the impact that these cell phones have made, or I should say, smartphones have made um, in a short while. You know, it was like 30 years ago. It was they were not around, and it's hard to imagine that such a tool can be
Yeah.
uh, accompanying you all the time. Uh, but it's changed a lot of paradigms by itself. And before space technologies, early investment in space research offended a lot of people. Why are we wasting our money on it?
Hmm.
But now we depend on it so much. A lot of things operate because of satellites. Um, and more and more of it is happening. We depend so much on the space technologies now. You cannot ignore it. Um, so it's hard to really predict future, but the general pattern is more and more automation, really different kind of humans, different kind of educational system, and very new frontiers that we cannot even imagine now. So that's why I really am passionate about technology.
Yeah.
I have worked on every, I mean, on multiple fields because I'm really, really absorbed in technology. Before you come, I had a meeting with a former colleague who's a scientist and knows a lot about the space and all. And we have been having a dialogue about space debris problem,
Uh,
about the space junk. And it has occupied my mind a lot. And actually, when I was in DC last few days, it was for a workshop on the space junk that I was conducting for the Space Force people. Uh, I don't know much about it yet, but I am constantly thinking about new ideas, which I think have potential and would like to pursue them.
your background's in manufacturing before contracting?
Well, yeah, but my field of interest has been manufacturing, yes. Um, but manufacturing involves a lot of technologies. Uh, Ever since like the 1950s, digital uh, control came into metal cutting and all that,
CNC.
CNC, right? And then in the 80s, robotics came in there. Of course, the advancements in microelectronics have changed manufacturing a lot, and what we're building today are amazing stuff. Which especially what's happening in China, you know.
I can only imagine in the beginning you must have been doing mail orders for parts and things.
Oh yeah, interesting, right? Yeah, we had to go when I wanted to build something. I had to go to there was something I think called Thomas Register.
Hmm.
We, they had many volumes of it, and every year they had to change them to update them. It was a list of companies that had different things. Or
It's like Amazon of the time.
yeah, Amazon of the time, and it was very hectic to find something, and then you send them a letter or order or whatever. I don't remember exactly the telephone. It took some time to get it, but right now, you know, you go to Amazon and Prime, and then overnight delivery.
Yeah,
It's
there's one
amazing.
guy in North Carolina who built a foam printer with just parts from Amazon that were delivered to his house, and
Right,
uh, yeah, was able to do a little foam dome with it.
right. Yeah, last Thursday, no, last Wednesday, I made an order for a very special sensor, and the origin was China.
Hmm.
Uh, it came Monday, yesterday.
It's great.
It's amazing. It was there, and they shipped it by DHL. Very reasonable shipping price too. Yeah, the world is really uh, much more ideal for people who want to change the world.
Yeah, it's great. Really great. It's like speeding up progress everywhere.
Right.
So you've got three printers and you're waiting until the right moment to enter the market.
Right. Well, the right moment partially is external, another is internal.
Hmm.
You have to make sure that we have the capability to provide service and support. These machines are relatively complex, you know. A small company cannot do everything.
Sure.
Right.
You have this office here. How much time are you spending on contour crafting these days?
Well, most of my time is
Hmm.
really here. Uh, uh, yeah, my involvement in the university is part-time.
Hmm.
I, I still do some research collaboratively with them, and I teach one course once a year, one semester a year, my invention course.
Cool. It's nice having teachers that have real world experience. That's kind of rare.
Well, but it's necessary.
Yeah, I agree.
It's necessary. You know, uh, I have mixed feelings about my education. You know, my experience in education.
Me too.
Yeah, there are issues. You know, the advantages of formal education like that is that you will be disciplined in a way. They force you to read and learn the content by the exams and homeworks and projects and all that. But problem is that you are asked to drink water when you're not thirsty, right? You're taking some courses in the curriculum without necessarily knowing whether these things are going to be useful to you or not. Uh, so there were so many courses that I was taking in the early years of engineering. I was wondering, why am I learning those? Because it weren't related to my target discipline. They were general purpose stuff. Um, and later on, even in my own discipline, there were courses that my preference would have been to read and learn that thing, not to that extent of spending one semester on it.
Hmm.
Things do not receive proportionally correct attention, you see, because everything has to be cut into chunks that would fit in one semester. Some of them are stretched, some of them are compressed. But self-learning has the advantage. So first of all, you learn what you need to learn at the time. And one thing leads to another, and gradually makes you special. when you go through a process that everybody else goes,
Mm-hmm.
more or less you're going to be like everybody else,
Yeah.
right? People who end up taking their own path in life, whether by choice or by uh, circumstances, they end up being more creative because the kinds of things that they know hardly has possibility of anybody else being exactly in the same position, having exactly the same perception and all that. So whatever makes you different is good, uh, because creativity is nothing but doing something that is different. To be able to do something different, you have to be different. So I believe this educational system is bound to change.
Yeah, I've always thought that, but being in the education system for so long, have you seen it change much?
Yes, yes, I have seen it, not as much as I like. Um,
Getting better, worse?
I think it's getting better
Good.
because of the YouTube University on
Mm-hmm.
the side and all the repository of amazing stuff on the internet. Uh, Students have more help
Yeah.
to expand themselves. If there is some ambiguity in what they don't understand in the book and the teacher is not explaining it well, there is another possibility to really learn it better. And you learn it at your own pace,
Mm-hmm.
right? You can go backward, come forward.
Watch double speed.
I personally was never right. I was never good in classroom. I always kind of had a hard time following because I kept daydreaming
Me
or
too. When I would show up.
and classes that I have been teaching, those formal classes. My invention course is different. Students really, because every time it is improvised, and
Mm-hmm.
students drive the discussions. They're engaged. But in other courses that I lecture, I typically sense that small band of students uh, are bored because I'm explaining too much to make sure everybody understands.
Mm-hmm.
Another wider band, they're totally out of it. It's obvious they're not following. And there is a middle one that is kind of in sync with you. So that just is a problem, right?
Yeah, I guess there's some people who are more inclined for the university learning system.
Uh,
How many people have the capacity to do self-guided education? And I mean, having a bunch of students, is it 10% of them could figure they're kind of bored in class and they'd learn faster on their own? Or is it 1%, 20%?
right. I don't know about the percentages, uh, but some students have to be disciplined, right?
Mm-hmm.
For them, that's kind of
Keeps them on track.
environment which forces them to understand, basically. Uh, Maybe good, but then it's questionable whether those students have to be forced to learn these things. They are probably good at some other things,
Yeah.
but they're missing that opportunity. Because I believe everybody has talent,
Mm-hmm.
everybody has creativity. People just have to find their passion, and trying to dictate a particular passion for people is not going to work. You try to make me a good musician, you're not going to be able to. I just don't have it. See?
What about software challenges? In the beginning, did you develop your own slicer?
I personally did not. No, no. I had students who, well, actually, we were using whatever was in the open market.
Mm-hmm.
First of all, yes, the the very primitive things that we were building, like in order to test the process, I was just making cylinders.
Mm-hmm.
A program I can write and all that.
One of the hardest things to make because you have so little time for the concrete to set.
Right, right. But it depends on how fast you build it and how big the object is. For those kinds of simple things, I programmed everything myself. But later on, when things become complicated, you know, complex geometries, you had to have slices. But STL generators very early on became available for free, and we were using those. Now, of course, when we get to this construction thing, situation changes, you know, depending on the nature of your nozzle, the kinds of objects that you want to build and all that, you have to have your own slicer. So we do everything from scratch here.
Do you think the batch plant mixer on site is an important development?
Batch plant mixer. Yeah, I have thought about that a lot, of course. It all depends on the logistics, right? Because it depends if you know, you have to have a silo for cement, you have to have a silo for sand, and if you have some larger aggregates, you have to have another silo for the other one. For those aggregate things, water absorption is a concern. I mean, knowing how much water is in it is important because it makes a difference. So in poured concrete, where proportion of water is not that critical, those things make sense. And a lot of large construction sites have piles of these materials there and use them. But for 3D printing, you really have to have the things under control. And managing them in separate silos and all that, and material transport and all that, the complexities of those worry me. So if you have everything in like bulk bag and already prepackaged for you, and it's plastic around it, you know, it's protected from moisture, well, that has a convenience and expected performance, reliable performance that could not easily be matched by batching stuff on site.
Typically in concrete, larger aggregate makes the mix stronger. But I read a paper you published in 2017 with Babak, where because of the, I guess, the slip flow, the smaller aggregate would go to the outside of the hose and the larger aggregate would be accumulated in the middle, and larger aggregate led to weaker concrete.
Yeah, it's you have to be cognizant of all those dynamics that can take place. But that's one thing that we observed at the time. But all of them, everything has a remedy if you do enough research on it, what to do. Right, you know, these are kind of nagging issues with construction 3D printing. I mean, that kind of printer, it's a plastic filament that goes in there, monolithic as far as the material is concerned, and there's not a mixture of anything.
It's homogeneous.
Homogeneous, right? Like I have tried many different ways of material delivery, wet and dry. So like one way for dry material delivery was pneumatic delivery, air delivery. Well, while it is really effective in a lot of other material transport, in this particular case, it causes segregation. Light stuff like cement goes first, and then sand, and then if you have gravel, it lingers along in the end. What you get at the destination is anything but homogeneous. Yeah, these are complexities that are involved in larger scale 3D printing. Large is another thing, right? You have to build large structures. Large structures are prone to deflection, bowing, and all that. They flex. Yeah, you can make them stiffer, then they become much heavier, and now you have to. The inertia will be higher, sluggish movement, and And then, of course, cost of energy to move them layer by layer to all these walls and all. So there are a lot of considerations that really make that pose some difficulties. At large scale, achieving high accuracy is very difficult.
Yeah, rigidity is something a lot of groups struggle with, especially around tight corners. You might see a wave pattern from a vibration created in the printer or something. Usually, a group's second iteration of their printer has way thicker supports.
Right, right.
Your system was on a or is on a track with one vertical axis.
Yeah, that was our second machine, which is cantilever gantry, right? Um, yeah, that has advantage. It could be, I don't know if you have seen the video of it, how it is deployed and quickly put. It collapses and gets on top of a truck.
The green one.
Yeah, the green one. Yeah, that's a neat solution. You don't have to set the rails on site and create a foundation for rails or whatever. You don't have to do any of that, and that's why the government liked it. Um, but everything has pros and cons. You have to deal with the deflection of this beam. It's gonna deflect, so you have to somehow program that into it. But that's much easier to handle than now if you have a machine that is structured around polar coordinates. You see, that one now prediction is very hard. What the orientation is, alignment and setup is more challenging and all that. The plain gantry, bridge gantry, you have a column on this side, is the simplest, cleanest way to set up and to have knowledge of all the deflections and all.
Does AI play any part in this?
Well, I'm sure at some point there will be more room for it. We have used some of that. We have used some deep learning stuff in relation to material preparation and things. But I cannot say that really made a big difference.
So early still for AI.
Yeah, right.
Another printer I saw, maybe this is one of the 3 models, or maybe it was just rendering, but you had a system that would roll up vertically the print as it went to build like 100-yard windmills.
Right. Yeah, that was basically a project that Siemens, the German company, the wind division of Siemens supported while I was at USC, building towers for wind turbines. But applications could be extended to building pylons and for bridges and all that, overpasses and things, for chimneys and any kind of tower. Yeah, we just showed the feasibility of the concept by building a small scale model and making an animation of the concept. I still think that thing holds a lot of promise. But problem with that kind of technology, as Siemens CEO, Siemens Wind Division CEO, correctly pointed out, was that experimentation with that approach is expensive. You have to spend $200,000 on concrete to build 100-meter tower to see whether you could build it or not, and then you have to demolish it and keep on building for progressive improvement as you learn. So it will be problematic. Not only the cost, but also the logistics of, of how to do all that.
Do you know the cost for them with the incumbent method?
Well, the cost for, at that time, this was
Sure.
2 years ago, the cost a at that time was 1 megawatt and 85 feet tower, the 85-meter tower, excuse me, 85-meter tower. The tower was $550,000.
So 200 would be good savings.
Yeah, right. If you can reach there, right, significant saving, and exactly the CEO said that this method can bring the cost of the tower, which is the most expensive part of the installation, by the way, could bring it to less than half of what it is right now.
Yeah, it's interesting. Now in 2024, there's a lot of companies printing concrete, but I don't think any of the companies doing homes are doing it cheaper than traditional homes would be. Maybe some of the use cases that are more cost effective are like custom one-off features where you're implementing creative designs and shapes, something that you're just doing one time where you don't have to make form work forward. Is that something you're interested in as well, or just buildings, mostly larger structures?
Well, as I told you, bottom line, my interest is in building low-income houses.
Yeah.
You know, and building them much cheaper. Of course, I want to do a service to them. I don't want to do this service. So yeah, that would be if I can make homes that end up being cheaper for the end user, then I would be satisfied.
Yeah, that's my primary interest doing it. The audience as well. It's very obvious to see the videos about houses do way, way better than a video about some seawall or a small architectural column or something like that. People want affordable housing really badly. It's just it's like the holy grail problem.
Right.
Have some of your students gone on to start their own companies?
Yes, actually. Well, several of them have gone after doing some startups, but 4 of them have been really successful in the startups. One now has his company, and they're all in 3D printing, either polymeric, photopolymeric, or metallic. One of them is about to go public now.
Cool.
It's got 5 branches around the world. The one here is serving the dental industry big time. You know, they're selling like 300 machines every month.
Wow.
Right.
What was your first exposure to 3D printing? You mentioned in the 90s you were trying to do large-scale polymer printing. Most people had never heard of 3D printing in the 90s,
Yeah,
right?
right. Okay, so I actually was exposed to it in McCormick Center in Chicago when I was attending a conference. In the exhibition, I saw the very first chalk hull stereolithography machine. I couldn't stop thinking about that, the potential of it. And on the flight back, I kept thinking about it. And on that flight, I basically independently came up with the idea of using powder instead of liquid, which SLS, basically.
Laser sintering.
Laser sintering. And when I came back, at that time, laser was not, you didn't even have laser pointers.
Wow.
You see, this is 1983, I think. Not everybody had lasers or access to it.
Was that conference mostly for CNC or all kinds of technology?
It was a manufacturing conference. I don't remember exactly what it was, but that SLA machine was being demonstrated there. So yeah, I came back with that idea of using powder and melting powder with laser. So I found at USC electrical engineering there was a lady professor who had a laser for her research grant. So I approached her and she said, yeah, you can use this. And I spent some time with it. When I found out that another gentleman, uh, Carl, forgot his name, Carl Deckard at Austin,
Mm-hmm.
University of Austin, had, had invented it as a graduate student. So, yeah, that became an obsession for me. I said, well, I have to make a powder-based technology that competes with that. Yeah, I eventually did that. It took a few years, but I came up with SIS for plastic. Um, yeah, Carl Deckard was an amazing guy. Unfortunately, he passed a couple of years ago. But he was amazing. I later on happened to meet him. I really liked the guy, his creativity, his wit, and everything.
Did any of your students ever pick up on the idea of implementing automation for plumbing and electrical? Too challenging?
No, nobody really did. Again, the very first step of this has so many problems that people prefer to just work on those. And if there's anything beyond that, a little bit other people have tried some sort of reinforcement to be added to the process, which are all good.
Mm-hmm.
But I think eventually in the course of the future thing, they're going to happen.
Yeah, I think it's just good to see more critical mass in robotics on construction sites, because whatever the solution is in the future, the more people that know how to implement software instead of using a hammer or a nail gun, it'll be easier to implement if you have a huge talent pool ready to go.
Right.
A lot of them taught by you at the school.
So we should also be mindful of the fact that other domains are not going to stay stagnant, like steel industry.
Mm-hmm.
That is going to be automated to a great extent. One puzzle for me is brick buildings.
Okay.
I went back to the history of bricklaying machines. It goes back to 1911 when an American guy invented the first bricklaying machine.
Wow.
After that, there have been many attempts at automated bricklaying, and right now there are companies that have them. There was a good company in Australia that came up with another approach.
2 episodes before this, I had their CEO on.
Oh, okay, right. But for some strange reason, I don't know why that doesn't take off. More than a century of effort in that. Why is it's not taking off? I have a very knowledgeable friend who is familiar with one of the technologies which was developed at CMU yes, CMU. And at Carnegie Mellon, basically. And he knows the people who have created that. Sam, I think is the name of the...
Yeah.
Right.
I think construction's robotics, they have the Mule and they have Sam.
Right. So according to my friend, he said that the problems with the technology, keeping it going without glitches and all that has always been a problem. But I hope that this will not be the fate of construction 3D printing, you see. Uh,
There's so many promising innovations looking forward. I can't imagine construction doesn't get automated some way or somehow.
right, right,
I
right.
don't try to predict exactly the way it will be, but you see like the Optimus robot Tesla's trying to come up with, her Atlas from Boston Dynamics. If those robots have hands, why can't they hold a hammer or mix
Right,
the
right.
concrete for the printer?
That's another possibility. And there are other ways of looking at automation as well. For example, some people are looking at building it at a micro level, having a lot of insect
Yeah,
robots
that's
or
cool.
whatever, putting the thing together like ants and honeybees build.
I love the
Those could,
ideas that are kind of originated from biology because evolution already did all the work to figure out how to make it happen.
right, but biomimetic is called. It's not always leading you in the right direction. For example, uh, trying to fly like birds really put aviation behind for several centuries,
Hmm.
because that is not the right way.
Flapping wings of an airplane.
Right, right, because biological things cannot have indefinitely rotating uh, components. Uh, then another issue with biological beings is that they have to have a lot of functions. They have to be able to eat, for example, and discharge. They have to um, give birth, right? Reproduction. And they are also subject to remnants of past stages of evolution, like the tails, for example.
Hmm.
This animal doesn't need anymore, but it's still there. It's a shorter one. Um, so just it's good to be inspired by nature, but you have to understand that nature has more restrictions than the gadgets that we make in certain respects. But we also have some disadvantages. Nature provides energy chemically so amazingly. You know, a little sparrow can fly for many miles with a couple of seeds that they eat, right? Super efficient energy wise.
Hmm. When you were considering projects on the moon, how were you thinking you would procure material to print with?
Well, of course, the only reason that my proposal was accepted was because I was proposing to use totally in situ material.
Hmm.
We call it ISRU, Institute Resource Utilization. While prior to what I had, the ideas really required things to be taken from Earth over there, either inflatable stuff or binder material from Earth. Basically, I demonstrated things with real materials from. Well, I will show you a piece of sulfur concrete that we built here. We built, I mean, not in here, at USC. There's no water used in it, and constituents of it are what is available on Moon and Mars. And it's a thermal process. It's not a hydration process.
Hmm.
It doesn't use water. None of them use water.
More like SLS.
Right, right.
What are all these toys you have on your desk, these electrical components?
Well, I'm constantly building stuff. I'm building like special sensors,
Hmm.
uh, some actuators that you cannot readily find in the market. Um, yeah, so yeah, I'm a builder, and I enjoy doing it. So I help the company staff with building some special stuff and uh, just conceiving new concepts. These are 3D printed parts that are going to be assembled with those rings and all that for um, electricity transmission
Ah,
for moving parts. Right,
on a concrete printer?
right.
Very nice. I see there's a small model of the
Yeah,
printer there.
right.
If I pick up the camera, can we take a walk around and see some of the concrete you printed?
Uh, concrete 3D printer.
Well, different things around you have the one small wall outside or over
Yeah,
there.
we can. Yeah, yeah. You can.
Let's
See
see.
that. Well, these are samples of sulfur concrete.
Sulfur concrete,
Yeah, made layer by layer.
thick layers.
Right. This one has a smoother layers. If you smell them, you smell sulfur, right?
Yeah, it does. Kind of like egg.
Yeah, you can look at different nozzles.
Which is the complex nozzle?
Yeah, this one. As you see, there are 3 outlets.
Ah. So that middle outlet would
Right.
go back and forth.
Yeah, it goes back and forth. These are some of the clay models that we built.
Mm-hmm.
Clay stuff.
What kind of clay?
This is the dish clay. They make ceramic dishes with them. So these are fired in a kiln after being made. This is one of the other double nozzle.
That
Or
does look
triple.
complex.
Triple nozzle, right.
So would
works
that-
pneumatically?
Facilitate a 2K material with some accelerant there?
No, these are air lines.
Okay,
This is a pneumatic with air pressure. It works.
fascinating.
Yeah, that's my NASA project.
Very cool.
You probably have seen this chart.
Many times. It's missing about 10 years though.
Yeah, right. After that, there have been other activities that have not been charted.
It's certainly an exponential graph.
Right.
Any more in there?
But let me move this thing back.
That's a really smooth wall.
Right. This is what we built with formulations that the Gusa showed us. Very
And
thin
so-
deposition.
Would you fill that with concrete?
Yeah, you could fill it with concrete. That was the intention.
And what's that small model over there in the chair?
Oh, it has been there. I built this earlier on at USC. To just demonstrate the concept of construction 3D printing.
Very cool. Well, thank you so much for giving me the opportunity to check all of this out, and I appreciate you answering all my questions.
You're quite welcome, Jared. You asked very good questions.
Thanks. We'll have to do this again when you release your systems.
Sure. You should come here, and when we print, you will see. You will take video and all that. Right now, it's a very chaotic situation. We're just trying to put this machine together and ship it. It's always very complicated.
Well, no rush, but when you're ready, let me know and I'll come right back.
Definitely.
Thank you so much.
Okay, my friend. Thank you for coming.